So this is on page 530. I'll give you a little bit of time. Try to do the first column, then we'll go over it, and then maybe the second column is easier. For sine and for cosine, remember that we have this formula. That your period is 2 pi over your b value. Will also be helpful for this. To remember that the zeros of a regular sine graph are k pi. So let's look at column 1. Did you get the period to be 2 pi divided by 2, which just ends up being pi? The amplitude is related to your a value. Your a value is 1. Does it make sense that your amplitude is 1? The domain, the x values, they're still everything. Our range, that's our y values. Well, if the amplitude is 1 and the center line is 0, it would go up to positive 1 and down to negative 1. It hasn't been moved left or right, so you can write none or you could write 0. There's no phase shift. Phase shift is moving it left and right. And the zeros, well, they were k pi, but you've had a horizontal compression where you multiply all your x values by 2. So your zeros would all get multiplied by half. Well, all your x values get multiplied by half with a horizontal compression. And so now, these are our zeros. The zeros were k pi, and now they're going to be k pi over 2. So now that you see the first column, take some time to do the next 3 columns. We'll go over it in a little bit. Yeah, because it was, yeah. It shouldn't be there. Lots of people have the answers up for column 2, so I'll add them so you can check. Period is still pi. Amplitude now is 1/2. Domain still goes for everything, but now center line is at 0 if the amplitude's a half. That'll change your range to go from negative a half to half. Still no phase shift. And the half affects the y values. That will not affect your x-intercepts. They will still be k pi over 2, where k is an integer.
Can we use range like square? So
Yes, you could do it like that as well.
I thought you said, yeah, it's really,
So yeah, it doesn't. It's the same as this one. The 2 still affects your zeros, so we still have the divide by 2, but we don't have the half doesn't. Ready to check the next two? Period's still going to be pi, right? Because it's always 2 pi over your b value. Amplitude is still your a value. It will still be a half. Domain, well, if the domain is everything, if you move it left and right, if you stretch it, it's still going to be everything. The range is going to be based on your center line and going up to your amplitude and down your amplitude, so it's still at negative a half to half. This time we do have our phase shift. We're going to go pi over 4 to the right. Can you see that that's going to change all of your x-intercepts? Your x-intercepts started at k pi. Then we had a horizontal compression, which multiplied them all by a half. And now we're moving them pi over 4 to the right. So now this is the equation of all of your x-intercepts. Whew. That's the most abstract part, yes.
Why doesn't that change your periods?
Because my period is how long it takes to repeat itself. So if it takes this long, and I move it over, it still takes that long. Right? If I move it left and right, my period doesn't change. And for the last one, period's still pi. That's just based on your b value. Amplitude is still a half. That's based on your a value. Domain is still everything. But now we have this minus 3, which is going to move your sinusoidal axis down 3. It moves your center line down 3. If your amplitude is a half, from minus 3 you would go up a half and down a half. So now, and you could write it this way, or if you like decimals, right? If minus 3 is your center line, then you went up a half, you get to minus 2.5. Down a half, you get to minus 3.5. That's your new range. You're still shifting your graph pi over 4 to the right. And now everybody can sigh some relief. Because if your range is between negative 3.5 and negative 2.5, does it have any x-intercepts? Finally, that one's easy. Usually what happens with sine and cosine graphs is you're asked to graph equations like this last one. So we're going to develop a technique to do that easier than our transformations. You could still use transformations. You could take your regular sine graph, take the 5 important points, center line, maximum, center line, minimum, center line, and do all 4 of these things to it. Just with the arrows, just like we did in transformations. But it's going to be a lot of mental math, and usually that mental math involves pi, and it gets tricky to label those things on a graph. So we're going to develop a technique that makes it easier. And you can write this on the top of page 531. The technique we're going to call DAB-C. It's called that because if you know the name of the technique, it will help you remember how to do it. It is a special order for graphing both sine and cosine graphs. And the reason it's called DAB-C is because you're actually going to start with the D value. And the DAB-C is just a way for you to remember an order to help you graph. For the shortcut, we're going to start with the D value, then the A value, then the B value, then the dash, then the C. So everything in the name is important, including the dash. So what does this mean? If you look at an equation, the first thing you're going to look at is the D value. The D value shortcut is it's the center line. So the first thing you're going to draw is draw your center line or sinusoidal axis. Once you've drawn your sinusoidal axis, the next thing you're going to look at is the A. The A is your amplitude. Amplitude is the distance from your center line, your sinusoidal axis, to a maximum and to a minimum. So the next thing you can do is you can use your amplitude and you can label what the maximum and minimum values are on your y-axis. Can I scroll to there? Is that okay? So we start with our D value. We draw our center line, we draw our sinusoidal axis. Then we go to our A value. The A value is your amplitude, and we use our amplitude to label the maximum and minimum, because you'll go from your center line up and your center line down. Your B value helps you calculate your period. So you do 2 pi over B to calculate your period. Then on your x-axis, you're going to label one period and divide it into 4 equal sections. Because every time we've had our period with 4 sections with the 4 quadrants, so whatever your new period is, you need to divide that into 4 equal sections. That's the DAB part. Now, before you use the C value, I said the dash was important. What you're going to do is you're going to use a dotted line and graph what your graph looks like before you do the phase shift. So the C value is your shift left or right, but before you get to that, you're just going to draw a temporary graph that shows the D, the A, and the B values. And finally, then your C value shifts it left and right. So what we're going to do is use our C value to take that dotted graph and either move it left or move it right. And this will make graphing sinusoidal graphs relatively easy. You can almost do them, I mean, there's DAB-C, that's 5 steps, but you can do all 5 of those steps on the same graph without having to show a lot of work, which is kind of nice. It's sort of like you do one thing that has 5 steps. So we're going to do a couple of examples. You can keep writing these examples on page 531, just to get practice with this idea of DAB-C. So here is our first one. And since the B value is 2 in green above, I used the formula that the period is 2 pi over the B value. I calculated my period right away to be pi. So as a start to this question, we can talk about all of the values. Can you see that your A value is 3? That's your amplitude. Your B value is 2. That calculates your period. Your period isn't 2, but you can use your B value to find your period by doing 2 pi divided by your B value. In this case, our period's going to be pi. At the very end, we're going to shift this pi over 4 to the right, and we know it has a center line of 1. So when I go to graph this, I take some of those things into my mind right away. I know that my center line is 1, so when I draw my axes, notice how I kind of have it scaled a little bit above, like I have room. I'm going to have room to go up and room to go down. And off to the side, I'm going to write DAB-C as the technique that I'm going to use just to remind myself what steps I've done and where I'm at. So in the DAB-C technique, we have to start with our D value. Our D value is the +1. All I have to do for the D part is I have to draw at y equals 1 my center line. D value is done. Next, I go to my A value. My A value is my amplitude. Amplitude is the distance from your center line to a maximum and center line to a minimum. So if I know my amplitude is 3 and I know my center line is at 1, if I go up 3, I'm going to get to 4, which is my maximum. Trouble again. And if I take my center line and I go down 3, 1, 2, 3, I'm going to get down to -2. So 4 is going to be my max, and -2 is going to be my minimum. And all we have to do with our A value is label our maximum and minimum on our y-axis. Next is the B value. Yes?
Is the amplitude the A?
The amplitude is the A value. The A value is 3. So I go from my center line, I count up 3 units to get a maximum of 4, down 3 units to get a minimum of -2. Now we've already calculated our period to be pi, so that's what we do with our B value. With the B value, find your period. Once you've found your period, mark it somewhere along your x-axis, really doesn't matter where. Here we go. There, I'm going to mark pi. And I have to divide that into 4 equal sections. So cut it in half and then cut each of those sections in half. Then you have 4 equal sections. We can label those 4 sections. I usually start by labeling the middle one first, because it's going to be half of pi. So that'll be pi over 2. Then I label the first one, because the first one's going to be half of pi over 2. It's going to be pi over 4. Then I can label the third one, because I know the first one's pi over 4. The third one's just going to be 3 of the first one. So it would be 3 pi over 4. Because if these are all equal, this is 1 pi over 4, and if I count, this would be 2 pi over 4, this will be 3 pi over 4. This is 4 pi over 4, which reduces to be just pi anyways. So we started by labeling pi, split it into 4 equal sections. It's easiest to label the middle one next, because it's just half of the first one. Then it's easiest to label the first one, because it's just half of the middle one. And then you can count 1, 2, 3 and label the third one. And that's all we have to do with the b value. So the b value is more work than the a and the b. Like the d, you just labeled your sinusoidal axis. Your a, you got your max and your minimum. Your b value, you have to find your period, label your period, divide it into 4 sections, and label all 4 sections. So the b value is a little bit more involved. Next is the dash. This is a coast graph. Does a coast graph start on the center line, or does a coast graph start at a maximum? Maximum. So I'm going to go to my maximum. Next ticking mark, I'll be at my center line. Next one, down at my minimum. Next one, back at my center line. Last one, back at my maximum. Be careful, you will be tempted when you go to your center line to sometimes accidentally label them on your x-axis, because you're used to that, okay? So it goes maximum, center line, minimum, center line, maximum. And we draw this with a dotted line. This is not our final graph. This is what our graph would look like if we didn't move it left or right. And that's what the dash is for. To draw the graph before a shift. And we have the 5 points labeled nicely. Finally, the shift. The shift is pi over 4 to the right. So we look along our x-axis. Is pi over 4 already labeled? Yes. We know how much pi over 4 is. It's 1 ticky mark. So we're going to take each of those 5 points and move them 1 ticky mark to the right, because pi over 4 is already labeled. Sometimes you have to add a label, like in the example we did earlier today, we had to add the pi over 6, and then you'd have to add marks for each of those. This time, moving it pi over 4 to the right, you will have to add 1 ticky mark to the right of the last one, because each of these points is going to get moved over 1 spot pi over 4 to the right. And now we have our 5 new points. Draw your graph through each of them. And it's very typical on the exam that they will say, can you graph at least 1 period of this? So we've got our 5 points. Those 5 points show 1 period. Add arrowheads to say that it keeps going. We've got at least 1 period drawn. This is the DABC technique. What's nice about it is you didn't have to do, like, can you imagine doing 5 points and doing, it would be y by 3, x by a half. And all of your original points would have like pi values in them, so it's like fraction work, and it would be a little bit annoying. Your chances of making a mental math error quite big. Okay, this makes it simpler. So we'll do, just to get good practice with this, we'll do another example. Any questions on this one? so far?
Yeah, this is
Mm-hmm.
do you take out the dotted lines or just leave them?
You can, again, a dotted line never is part of the graph, it's just there to help you, so you can leave it. If you draw it as a solid line, you would have to explain yourself why there's extra lines drawn. But as a dotted line, perfectly fine to leave it, you just use that to help. So let's do one more. We'll write dab C. I kind of think about the D and the A value right away when I'm going to start drawing my scale, because it depends where I'm going to draw my axes. Like for example, in this one, I'm kind of thinking about my maximums and minimums already when I draw my scale. Because starting with my D value, I know that my center line is going to be at y equals -2. That's all I have to do for D. And I know with my amplitude, now it's a -4, but amplitude is always a positive number. The negative is a vertical reflection. So this is a sine graph. When we go to draw our dotted line, a sine graph starts in the middle going up, but because of the negative, we'll start in the middle going down because we've had a vertical reflection. But that will show up in the dotted line. Right now, my amplitude is still 4, so I can label my maximum is going to go up to 2. And I know that my minimum is going to go down to -6. My B value helps me calculate my period. So in this case, the formula says period is 2 pi over my B value. My B value is 3, so my period's going to be 2 pi over 3. Choose somewhere along your x-axis and make it 2 pi over 3. Doesn't matter where, because you make up your own scale. Once you have that, divide it into 4 equal sections by cutting it in half and then cutting each of those parts in half. We need to label all 4 of those sections. The easiest one to label is going to be the middle one. If the whole thing is 2 pi over 3, half of it would be pi over 3. Does that make sense? Half of 2 pi over 3 would be 1 pi over 3. And then half of pi over 3, well, if you multiply pi over 3 by half, multiply the tops, you get pi, multiply the bottoms, you'll get 6. Pi over 6. Then to label the third one, if this is 1 pi over 6, does it make sense that this is 2 pi over 6? And the third one will be 3 pi over 6. And you can label it as 3 pi over 6. You can label it as pi over 2. Both are fine. I think I usually just go with 3 pi over 6 because I'm counting. But if you would like to redo something, you can. So again, the B value in dab C, that takes a little bit longer. Next, we draw the graph without the phase shift, with a dotted line. So what kind of graph do we have? A negative sine graph. Sine graph normally starts in the middle going up, but the negative says we'll start in the middle going down. So if I'm starting middle going down, I'll go middle, minimum, middle, maximum, middle. And that's what we do for the dash. Then finally, we're going to draw our final graph. I'll do it in green. We need to shift pi over 6 to the left. So first on my scale, is pi over 6 listed? Yes. I know that pi over 6 is this distance. I need to go to the left, so I'm going to have to label one ticking mark of pi over 6 to the left. Now each of these points is going to get shifted over that distance. Right, so that one goes pi over 6 to the left. This one will go pi over 6 to the left. That top point will go pi over 6 to the left. And since pi over 6 is the length of one section that we chose, it's easy to shift it pi over 6 to the left. Now we can draw our final graph with a solid line. With arrowheads on to say that it keeps on going. And that is the DABC technique. Question?
Could you do an example without the change being equal to the numbers?
Without the change being equal to one of the numbers? Yes, we'll get that. Let's see if our next one has the same shift. Should I just make up another one? Do you want it? No. Do you want it like to make your mind go a little bit funny, but not too bad? Okay, we'll do another one. Okay, I'm going to introduce some stuff in here which is going to seem a little bit funny at first, but it's going to work out just fine. So this is our third example. Where do you have space? Do you still have space on the same page?
Yes.
Maybe you flip back. There's lots of space on page 529. So why don't we do this example on page 529? Okay? How much fun do I want to have? A lot of fun? Okay. I'm going to do a negative coast graph, just because the negatives are good to practice. We're going to get a little bit crazy by having my b value be pi over 4. That's a little weird, but it's okay. We're going to shift 1 to the right and have a +2. Okay. Well, let's write out DABC. And in our DABC, can you see that your D value is 2 and your amplitude is 3? So when I go to draw my scale, I know that my D value is going to be 2 and my amplitude is going to be 3. So I have an idea already with my max and min when I start my graph. But now we can go to our D value and we can label y equals 2. The D is done. Even though there's a -3, your amplitude is still +3. I'm going to go up 3 and get to 5. That's my max. Down 3 to -1. That's my minimum. My amplitude is done. Now I made the period a little bit more difficult on this one because if I go to my formula for period, my formula says take 2 pi, divide by your b value, and my b value this time is a fraction and it's pi over 4. So at first we might get a little scared. But this is just work with fractions. You guys, if you found fractions hard in grade 7, you've done lots of fraction work now all the way to grade 12. The rules for fractions are not that bad. What's the rule for dividing by fractions? Multiply by the reciprocal. So I would have 2 pi over 1 multiplied by the reciprocal, 4 over pi. Oh, this actually is really nice. My pi's go right away. And 2 times 4 is 8. So my period is 8. And 8 is okay. It feels weird because we haven't done any questions with just a regular number on the bottom, but it could happen. Then you have to divide this into 4 equal sections. What am I going to label the middle section as? 4. And the first section would be 2. And the third section, 6. So I did this because now we could have numbers. This is perfectly fine. It's okay that there's no pi's listed on the bottom. Perfectly fine. Now we've done the b value. Next we draw the graph with the dash. It's a coast graph. Coast graphs normally start at a maximum, but it's a negative coast graph, so this one starts at the minimum. Then we just go minimum, center line, maximum, center line, minimum. And that's your dash. Now the reason we did another one was so that what happens when your shift isn't one of your ticky marks? What do we want to do? We want to shift 1 to the right. But my scale goes by 2s. So we have to find out where 1 is. Now, this is easy now because I'm using whole numbers, but I figure out where 1 is, and then I'm going to have to add a ticky mark of 1 to the right here, 1 to the right here, 1 to the right there, and 1 to the right there. And we shift each of our points over 1 ticky mark. And we have our final graph. So with that we can go, we have time to do example 1, and example 1 is more of the same. So if we scroll we're going to skip A. Well, we're going to do A very quickly. Let's do A very quickly. Predict. Can you see that this is the 1/4 does 2 things now. The 1/4 is still a vertical compression. So you would multiply your y values by 1/4. Your y's get multiplied by 1/4. It is also, as a shortcut, tells us our amplitude is 1/4. Okay? Next, switch colors here. The b value, we can still think in transformations. This is going to be a horizontal compression. We're going to multiply our x values by 1/3. But we also know now that our period is going to equal 2 pi divided by 3. Switch colors again. The pi over 6 is a horizontal translation. Pi over 6 to the left. And sometimes in this unit they use the word phase shift. or horizontal translation. Don't you wish in math sometimes they could just just one word is enough. Just call it x-intercepts. Don't also include solutions and roots and zeros. Why do we have to come up with 4 words for the same thing? Can't it just be a number or a value? Or, oh my goodness, we do it all over the place. So many words. Yeah, okay. Horizontal translation, pi over 6 to the left. And then lastly, one more color here. We could still call this a vertical translation to up, but now we know that it's also our center line or sinusoidal axes at y equals 2. So we're predicting, but we don't really need to predict. We know what each of those things stand for. We could talk about them with transformations. We can also talk about them with our shortcut and what it stands for now. Okay, so if an exam question asked you to describe what's happening, either one of those words would be acceptable. Next, sketch the graph. I'm going to underline this, and I'm just going to point out that this is annoying, what the textbook did here. I just feel like ignoring it right now. What we're going to do is, instead, this is more often what happens on the exam, they ask you to do at least 1 period. That's what we'll do. If we have time before the bell, I'll do the annoying part for you, just so you can see how annoying it actually would be. Okay. We don't have to list the characteristics because we did it already above in the prediction. So, we're going to sketch, we're going to use DAB-C to do it quickly. I know my center line is 2 and my amplitude's only 1/4. So I'm thinking already, look, notice how big I made my ticky marks in this case, because I knew my center line was at 2. So I can label that y equals 2, I can do it. D value is done, but my amplitude is only 0.25. So I'm going to go up to 2.25 and down to 1.75 for my maximum and my minimum. It's really squished. So again, I thought about my scale beforehand because I knew that if I did something smaller, my graph would be super squished. So I've labeled my max and I've labeled my min. I can use my formula for period. I did that already. I'll write it again, 2 pi over my b value. Choose a point somewhere on my x-axis for 2 pi over 3. And divide it into 4 equal sections. Cut it in half, pi over 6, oops, pi over 3. Cut it in half again, get pi over 6. 3 of them would be 3 pi over 6 or pi over 2. Oh, I'm behind on my check marks. I did the A already, a long time ago. And now I've done the B. The DAB part is done. Next, draw a dotted line. What kind of graph is it? It's a coast graph, a positive coast graph. Where does a coast graph start? At a maximum. Then it would go to center line, then minimum, then center line, then maximum. It's a really skinny graph. Then our phase shift, we want to go pi over 6 to the left. I have a ticky mark of pi over 6, so I can label. This will be going one thing to the left. So this point will go here, this one to here, this one to here. Oh, in the dash. And now I've done the C. This is at least 1 period. You can circle 4, 5, 6, and 7. And I'll show you what would be annoying with what they wanted. They want to go to 2 pi and all the way back to negative 2 pi. Okay? 2 pi over 3 that we did is this divided in 3. So this is where 2 pi over 3 would be. And our 4 sections that we did were right here. You would still have 1, 2, 3, 2.25, and 1.75. And you would still have your center line here at 2. Our dotted line, when we did our dotted line, was there. And our green line shifted back to there. This is what we graphed, was this little part. Why this is so annoying is the textbook would say, well, you still have to have this divided into 4 equal sections, and then this divided into 4 equal sections, and there would also be all of those. And we went from maximum to center line to minimum to center line to maximum to center line to minimum to center line to maximum to center line to minimum to center line to maximum to center line to minimum to center line and back and minimum to center line. Oh my goodness! And I am doing it quick right now because the bell's getting tight. And then you would have to connect this whole thing together and stop at 2 pi and stop at negative 2 pi. I don't even know if I'm at the right spots because it's annoying, hence what I wrote at the beginning. So it's nice that the exam and my test will say for at least 1 period, but this would be what they were looking for. Oh, and supposedly if I'd drawn it to scale, this would be a nice, smooth, repeating curve that doesn't have any abnormalities in it like it does. But have a great extra long weekend. See you guys on Tuesday.